Welcome to Geometry Pre-AP. Go ahead and write the vocabulary down here and the essential understanding, and pause the video and get those things down. Okay, so now that you have that all that vocabulary down, the essential understanding is parallelograms have special properties regarding their sides, angles, and diagonals. So this video won't be too long. We're just going to go over the properties, but before we do that, let's talk about the parallelograms and their properties. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. Okay, so this and these following pieces of information are true. Okay, some of the information about a parallelogram is it has opposite sides, so A, B, and CD are opposite sides, and then angle A and angle C would be opposite angles. So there's opposite sides and opposite angles. Angles in a polygon that share a side are called consecutive angles. So B and C are consecutive angles. So would A and B be consecutive angles. So there's different pairs of consecutive angles. Now we do this vocabulary because we're going to use this wording when we talk about our new postulates and theorems. So make sure you highlight your postulates also. You don't have to write them down if you highlight them in your postulate and theorem sheet. All right, so know the following list of properties. Once you know the properties, the rest is applying the properties and then solving the algebra. So our first theorem is theorem 6-3, and it says if you have a parallelogram, then opposite sides are congruent. So here we have AB is congruent to CD and BC is congruent to DA. All right, our next theorem is theorem 6-4. It says that if a quadrilateral is a parallelogram, then the consecutive angles are supplementary. So that means like if you have this parallelogram, then A and B are supplementary, B and C are supplementary, C and D are supplementary, and D and A are supplementary. And I don't like how that showed up. Okay, so we got supplementary angles. So that's our next theorem. Here's our third theorem, which says that if you have a quadrilateral that's parallelogram, then the opposite angles are congruent. So that means if we have this parallelogram, then we have B and D congruent, or A and C are congruent. Opposite angles are congruent. And finally, our last theorem says that if you have a quadrilateral, then the diagonals bisect each other. That means that if you have this parallelogram and you put diagonals in there, then these two parts are congruent and these two parts are congruent. All right, and so those are your properties of a parallelogram. So if we look at this basic parallelogram here, we look at this equation, we have this piece is congruent to this piece, and we have this piece is congruent to this piece. And so we're going to have two variables here. So when you're thinking about this, we're going to use a system of linear equations. So the diagonals bisect each other, which means we have these two pieces are congruent. So we can set up a system of equations, which is x plus y, or y plus 10 is equal to 2x minus 8. And the second equation is x is equal to y plus 2. Remember that when you're going to solve a system of equations, you got to get them lined up. So you got x's and y's lined up. And so in this equation, it might be easier to use substitution since x is equal to y plus 2. So we'll just use substitution. So we take this right here, and we plug it in right there so that we can get a system of equations. All right, so this piece went right there into the equation. So this is what we have. Y plus 10 is equal to, oh no, that's not right. We've got this is x, and so it's going to go right there. All right, and so let's plug that in there. Once you plug that in, you take out the x and you replace the y plus 2. You got to distribute, and then you solve for y. Once you have y solved, then you're going to plug it back into one of these equations so that you can get the x value. And so we plug it in, x is equal to 14 plus 2, we get 16. And so we know our values of x and y, and so we can plug them back in to get km. Km is equal to 2 times kp, because the segments are bisected. And so then we end up that km is equal to 48 and ln is equal to 32. All right. Now that's one way to solve a system with substitution. I like the elimination method. You can use either way, but remember that not every system of problem is easy to do with substitution. All right, so once again, let me remind you, there is not much more to teach you because it's basically just knowing the properties and applying the properties over and over again to a figure. So keep your properties close by. I would say have these pictures. Even though you highlight these theorems, I would have these pictures so that you can know what to look at to help you with setting up your equations. All right, and that's the end.